Hello everyone and welcome to today's video on problem solving. Problem solving is, and I cannot overstate this, the most important and critical skill that you can develop as a computer programmer. If you get nothing else out of this class, I want you to learn how to be a good problem solver. The reason that problem solving is so important is that problem solving is at the heart of what a programmer is. Because computer programmers are just people that solve problems. So if you do not know how to solve problems, you will not be a good programmer. It's also the reason why employers are willing to pay so much for a good programmer, because problem solving is a really hard skill for people to develop, and the ones that have it and are good at it are worth their weight in gold. So if you want to be a great programmer, you need to learn how to do this. There are three main steps to problem solving. They're decomposition, which is breaking a problem down into smaller and smaller problems. The reason why this is useful is because smaller problems are easier to solve than larger problems. And if we have a whole bunch of solutions to our small problems and we put them all together, we'll be able to solve our big overarching problem. There's also organization, which is ordering your solution in a way that's easy to understand, update, and extend. If your solution is well ordered, it's going to be easier for you to know what's going on and for your partner or your fellow programmers that happen to be working with you, right? If you understand what's going on and your code is organized, you're going to know where to make fixes to things if things are breaking, or if you're encountering certain errors, where to go look to address that, or if you need to add features, where those things should be placed. Code is organized, doing all these things is going to be very easy. There's also abstraction, simplification of an idea or concept by ignoring unimportant details. A good example of this is thinking about a car, right? A car has many different components. It has a chassis, it has seats, it has a wheel, it has an internal combustion engine, it has tires, right? If you're the person that's responsible for building the tires, you do not need to know the ways that an internal combustion engine works, how it needs to be built. But you might need to know other things like what's the texture of the asphalt, or maybe how much power that engine produces, know how to build tires correctly. But if you're able to ignore all the things that aren't important and able to focus on just the things that are for your particular part of the problem, you're going to be able to state the solution in a much easier way. Another way of thinking about it as abstraction is to only deal with the details when you absolutely have to. If you do not develop these skills, you're going to be DOA, dead on arrival, in both this class, future courses, and if you somehow make it beyond those, in your job. You're not going to be there long if you do not develop these skills. And so, what I want to share with you is my problem strategy that I've come up with over the last 11 years of being a programmer, and hopefully use this information to help you grow a lot quicker and avoid making the mistakes that I was making when I was first learning how to program. The first step that I always take when solving a problem is to solve some examples by hand. The reason that I do this is to explore the problem a bit more and actually figure out what it is that I need to do. If I don't know what it is that I need to do, I'm not going to be able to explain to the computer what it needs to be able to do to solve the problem. Doing these examples is also going to allow us to find patterns which we can exploit to solve the general problem. These examples might also show us parts of the problem that we never considered and allow us to build solutions that could tackle those particular parts of that problem. When you're doing this, you're going to want to work with small problems because the patterns are going to be there whether the problems are large or big, and you want to be able to solve these by hand. When coming up with these examples, you're going to want to come up with small problems because patterns are going to be there no matter how big the problem is, and you want to be able to actually solve these problems by hand. And it's easier to do that with a small problem versus a large problem. After you've done some examples by hand, the next thing that you need to do is take a step back and ask yourself, what is it that I just did? What are the steps that I'm taking in order to solve the problem? You're going to want to keep these steps as large and as broad and as general as possible. There's no need to get into all the nitty-gritty details. Talk about the way that you're solving the problem in the way that you actually solve the problem. list what you're doing. If you happen to run into the issue though of you're just at the point where you're saying, I just did it, well, you're going to have to go and try out some larger problems and larger problems until you get to the point where you actually have to solve it. Because you can't tell the computer just to do it. Because the computer doesn't have any intuition and is not able to just solve the problem. You have to be able to tell it what to do. So if you don't know what it is that you're doing, you're not going to be able to tell the computer what to do. Increase the size of your problems until you actually have to think through the problem and work through it. After you've come up with your steps, it's really important to write them down. Think of this as the outline for your program. Just like an outline for a paper helps you write a better paper, having an outline for your program is going to help you write a better program. When you're writing your steps down, again, keep them big. Don't get into the details yet. Practice that abstraction. You should also avoid mentioning any coding constructs in your solution. As soon as you start thinking in code, you are limiting your ability to think, and it's going to make the problem much more complicated. Keep your solution in English. Keep it general. Keep it easy to understand. And leave those details for later. You're not going to tackle them right now. When you write your solution, though, it needs to be clear and concise. Someone without any programming background should be able to understand what it is that you're saying. And if you handed them those steps and you told them to do this, they should be able to solve the problem. Now that you have your steps, it's time to apply them to an example to see if they work. So try out your steps on either an example that you've done or preferably a new example. If you're working with a partner, now would be a great idea to give them your steps and have them see if they're able to solve the problem. If they're able to solve the problem based on what you've said, great, you've probably written a fantastic solution. But if they run into areas where they're confused or don't understand what's going on, you probably need to add in a little bit more detail and state what should happen. But at least you know that now instead of later. If your solution works on these problems, you're good to go. Move on to the next step. But if they don't work, that means you have some issue with your logic and you need to go do some more examples, solve them, and figure out what your error happens to, right? And correct your solutions that solves the problem correctly. Hopefully when you're doing this though, your solution doesn't end up being unintelligible and just a patchwork of conditionals, right? You don't want to be able to say if this happens or if this happens or if that happens or if this other thing happens or if this other thing happens, here's all the possible things to do. That's not to say that there shouldn't be if statements in your solution, but just that if statement should probably not dominate your solution and you should be able to solve most of the problems in a general way. So now that we know that our steps solve the problem, we need to go turn our steps into code. And here I've listed common things you might say in your solution and their corresponding coding constructs. Your big steps that you come up with, they're going to be functions. And you're going to want to write a lot of functions in your code because you're probably going to have a lot of big steps. More functions is probably a better thing versus having a few very large functions in your code. If you say if this, then do that, it's going to be an if statement. So if you're hungry, eat. If you're tired, sleep. Otherwise, do some homework. Otherwise, go play, right? An if, elif, else statement. If you say keep doing something until something happens or while something is happening, this is going to be a while loop. So keep walking until you're home. Keep eating until you're full. While you're tired, keep sleeping. If you're saying things like this, it should be a while loop. And if you say for each thing, do something, it's going to be a for loop. So for each student in the class, grade them. For each piece of laundry on my floor, put it in the dirty clothes hamper. For each dish in the dishwasher, put it away. Those are going to be for loops. And when you're thinking about how to write your steps, you should try to use these words in your solution to help make it easier for you to translate your code later on. These last four things have to do with object-oriented programming, and we will review them once we get to object-oriented programming in the class, but I just wanted to bring them up so that you're aware of them, seen them, and you can kind of think about them and mull them over. If you have things in your problem, they're going to be represented using a class or an object. So if you have a person, a cat, a dog, a tree, a refrigerator, a car, wheels, tires, engines, these things should all be classes because they are all things. If one thing has another thing, or if one thing is made up of another thing, that's composition. Since a car has wheels and has an engine and has a steering wheel and has seats and has a chassis, those things should all be members of the car class. If a thing does something, then your thing should have that something as a method. So maybe you have a player in the game and they're able to make a move. Making a move should be one of the player's method. If you have an animal and they're able to make a noise should be one of the animal's methods. If your animal is able to eat something, eat should be one of the animal's methods. Then finally, there's the is a relationship. So if thing A is a thing B, this means thing A should inherit from B. So since a car is a vehicle, a plane is a vehicle, a train is a vehicle, all of these three things should inherit from vehicle. Since a circle is a shape, a rectangle is a shape, a triangle is a shape, circle, triangle, and rectangle should all inherit from shape. At this point in time, we'll have translated part of our solution into code, but we won't have the whole thing there in a working program. This is because we're using those big general steps, which resulted in a lot of empty functions. That's perfectly okay. We're going to be able to fill those in, and we can do so by repeatedly applying this process. We're going to want to keep breaking things down and breaking things down and breaking things down until we finally get to functions that are going to be very trivial to write, only requiring a few lines of code to do so. Preferably, these functions should be able to fit within 20 lines of code. If you're not able to get your functions down that small, well, you need to keep working at it. Break it down a little bit more, break it down a little bit more, break it down a little bit more. Because there's always going to be some subtask that you can find to be able to describe what it is that you want to do better as a function than as the composition of the lines of code that make up that function. Now that we've written our code, it's a good idea to actually test our code. And I would recommend writing test cases as you go along. Every time you write a function, write a test case that tests that function. And you should be utilizing a unit test to do this, which we'll cover later in the class. And it's much better writing these tests as you go because you'll be able to root out bugs along the way and your mind is still going to be in that part of the problem. Whereas if you wait until all of your code is written and you're done, it's going to take a lot more effort for you to be willing to write those test cases because you're going to have to write a lot more of them all at once, and it's going to be a lot harder to test. And one of the key things is each of your test cases that you write, it should test one function and one function only. If you test one thing and one thing only, and you see that the test case that tests function X is breaking, that means your error is going to be in function X. And so you're going to know right away where to go look to solve the problem. But if your test case is testing a lot of different aspects of the program, you're going to have to look in a lot of different places for those errors. Now, you probably, if you're like me, made some mistakes, and you need to figure out where you've made those mistakes and how to fix them. Again, running the test cases should give you a rough area of where those problems are at, but a lot of times you're going to need more information than just my test case is failing. And the debugger is the best possible tool that you can use to help you figure this out. The debugger is going to be able to show you exactly what your program is doing at every point along the way. And if you have that information and you know exactly what's going on, you're going to be able to compare it against what you expect to be happening and be able to figure out where the error is at from there very, very quickly. So use that debugger. It's the best tool that any programmer has, and it will save you hours and hours and hours of your time. So in summary, have 8 steps. Solve some examples by hand to figure out what it is you need to do to solve the problem. Reflect on what you did to be able to get those steps that you used to solve the problem. Write out those steps of the problem to form an outline so you have a goal and you have a plan and you know how to solve the problem. Test out your steps that you came up with in part 3, see if they actually do solve the problem and it does work. translate those steps into code, write tests for your code. If things are breaking, debug it to figure out where the problems are and fix them, and repeat the process for each new subproblem that you come up with. Now, before we move on, there are a couple of common problems that I'd like to run through, so hopefully you don't make these mistakes as well. The first is just jumping straight into the code. A lot of people think that because you're evaluated on your code, that the most important part of this class is writing code, and you need to start writing that code as soon as possible. That's a mistake. The big part of this class is to help you think about how to solve problems and give you tools to solve them, not for you to really write code. If you just jump straight into your code without having thought about how to solve the problem, you're going to have some confusion. And that confusion is going to result in you writing confusing code because your code is your thoughts and you're going to put those confusing thoughts down. This confusing code is going to be hard to understand. You're not going to be quite sure what it is that you're doing, which is going to make you more confused. And this confusion will compound upon the confusion, making it taking you a lot longer to solve the problem. This is probably going to double or triple the amount of time it's going to take you to solve the problem if you just jump straight into it without a plan. This lack of a plan is also going to lead to disorganized code. This disorganized code is going to get harder to work with. It's going to be harder to understand, harder to update. When things are breaking, you're not going to know where to look, all because you didn't have a clear picture of what you wanted in the end. So don't jump straight into the code. Follow this process. It might, again, seem like more work, but it's going to save you a lot of time in the long run. The next issue is building your solution bottom up, which just means starting with the smallest part of your problem, implementing that part, and then building on top of those small parts. A lot of people like this because they can see their code working as they're writing it. But the problem with doing things this way is you're going to assume how your objects that you create at this layer and how your functions that you create at this layer will be interacting with the functions and objects at the layer above. And while a lot of your assumptions are probably going to be right, you're not going to be able to predict everything perfectly, and you will make some mistakes. And you will want to call functions differently or move data elements around between different objects, which is going to cause you to rewrite your code. And this rewriting process isn't going to happen just once, it's probably going to happen multiple times. As you move up from one layer to the next, there's going to be some incorrect assumptions which might require you to rewrite all of the layers below. And so this wastes a lot of time because you didn't have a clear picture of how things were interacting. If you approach the problem like I've been talking about, which is called top down, you'll be able to avoid this issue because you'll already think about how you want things to work together, and you'll already have called them the way that you want, that you have your functions accept the correct arguments, set them in the correct order, and it'll save you writing a large portion of your code. The next mistake that I see a lot is not writing test cases. If you're not writing test cases, you're essentially saying, I write error-free code. I don't do that, and I know you guys don't do that as well. So don't behave in that manner. If you don't write test cases, you're going to be forced to debug your entire program all at once, which is going to be a lot more complicated than debugging the individual parts, because there's going to be a lot more code running with a lot more interactions between these different parts. So locating the source of your error is going to be a lot more complicated. If you followed my advice and you have your test cases only testing one component, you're going to know when things are breaking. Again, if the test case that tests function X is failing, then it probably means your error is in function X, and you know where to go fix things at. These test cases are also really easy to write. It should only take you a handful of minutes, if that, to write them, but doing so will probably save you a lot of time down the road. And it's also going to allow you to have a lot more confidence in your code because you've seen that it is working and you know that it's working to the best of your ability. The next issue, and probably the one that I see the most, is not using the debugger. A lot of people default to the tried and true method of just looking really, really hard at their code to be able to see what's wrong with it. That tends to be a really poor strategy for finding your errors, because when you wrote your code, you assumed that you wrote the correct thing. And so looking at it harder isn't going to reveal any problems because you think your code is correct. And why would just looking at it more help you see where the error is at? What you need is someone pointing out the issues to you about what's actually happening so you can compare that against what you expect to happen and figure out where things are going wrong. And this is exactly what the debugger does. It shows you what's going on in your program so that you can find those bugs quickly. It's going to take a little bit of time to learn how to use the debugger, and we're going to cover that later. The time that you put into it is going to save you hundreds of hours here at university and hundreds to thousands of hours in your actual job. So taking an hour or two to learn how to use the tool and actually practicing with it is going to lead to huge savings overall in your life. All of these mistakes that I've kind of mentioned really aren't necessarily mistakes. They're more ignoring this advice that I'm giving you. Again, I'm trying to give you years worth of advice distilled into a couple of steps for you to follow, help you become a much better programmer much quicker. But every year that I give this advice, most of the students ignore it for their own detriment. And a lot of times I'll have them come back when they finally realize they should have been doing this, and they'll tell me, yeah, Matthew, I really should be solving problems this way, and this is the way that I'm doing it now, and it's saving me so much time, and it's making all of my classes so much easier. So don't learn this through the school of hard knocks, which is how most of us have had to learn it, but take this advice to heart, try it out, and apply it, and see if by doing this, it actually does make your life easier. And I'll be honest, there tend to be three types of people that come to this advice. There's the first group, which is the group of you that's already kind of figured this out and you've been applying it without even knowing it, and you've been succeeding and doing really well. There's the second group of you that haven't quite figured out that this is the way that you should be doing things, but eventually will, and you'll be kicking yourself right now for not actually having to apply it once you kind of see the light later on. Finally, there's the third group of people which never learn how to follow this advice and never start problem solving before they start programming. And those are the people that tend to find programming too hard and end up dropping out of the major because they can't make it because they're not able to solve problems because they're not trying to solve them in a disciplined way. I know this has all seemed kind of abstract, but we're going to be going over in a couple of videos after this one some examples of actually applying it to real life problems, one small, one large, so you can see how it can make your life easier. I will see all of you guys in the next video, and I hope you have a great time until then.